Hello, namaste everyone. Hope all of you are well. Today we are going to discuss lecture number 3 of S block elements. In lecture number 1 and lecture number 2, we have discussed about what is alkali earth metals, how are their occurrence, electronic configuration, ionization enthalpy, hydration enthalpy, physical and chemical properties, and the uses of alkali earth metals. Before moving towards the alkaline earth metals group number 2, we have to discuss some general characteristics of alkali earth metals and their compounds. Means general characteristics. Now you can ask me, sir, what are their general characteristics? So I would like to say you in the form of oxides and hydroxides of alkali earth metals, in the form of halides of alkali earth metals, in the form of salts of oxaloacids of alkali earth metals, what is the anomalous properties of lithium, what are the similarities and difference between the lithium and other alkali earth metals, what are the important compounds of sodium as washing soda, baking soda, caustic soda and sodium chloride, and the main important about the biological importance of potassium and sodium. So these are some general characteristics. So let's begin with the oxides and hydroxides of alkali earth metals. Now question comes here, sir, how will you say about the oxides and hydroxides? So generally we have learned about the alkali earth metals from lithium to cesium, right? Lithium, sodium, potassium, rubidium, cesium. And francium is radioactive element, so we have not studied about it. So lithium, sodium, potassium, rubidium, cesium. As we have seen that generally lithium reacts with oxygen to form lithium oxides. Means here monooxide, you can say Li2O. But dear students, I would also like to say you the lithium can form lithium peroxide also. Okay. So here in the case of lithium peroxide and lithium oxide, first of all I hope that in the chemical properties of alkali earth metals, means lecture number 2, I have informed you that lithium gives monooxides, sodium gives peroxide, potassium to cesium gives superoxide. If you have seen and watched lecture number 2, then you can understand about it. If you have not seen, then first go in my channel, just watch lecture number 2 and then come to this one. Okay, so first of all I would like to say you on the combustion in the excess amount of air, the lithium forms mainly lithium oxide. Excess amount of air, lithium will form lithium oxide. Remember dear student, when there is an excess amount of air, that time lithium will form as a lithium oxide. Now question, in some of the peroxides means oxygen self-link, lithium also forms lithium peroxide and sodium also gives sodium peroxide. Means as you have seen about the lithium and sodium, so we can say that in some compounds lithium also gives lithium peroxide and sodium gives sodium peroxide, right? And rubidium to cesium, they give superoxide. Superoxide in the forms of, if they react with O2, they will give metallic oxide, MO2, in the form of MO2, that is superoxide. I have already informed you these things in the lecture number 2. So what you have seen, that if we compare all these alkali metals, so in the form of oxides MO, M2O, M2O2 and MO2, right? These three as you have seen, right? M2O, M2O2 and MO2. This may be prepared. The increasing stability of these peroxides or superoxide as the size of the metal ion increases is due to the stabilization of the large anions by the large cations through the lattice energy effects. These oxides are easily hydrolyzed by water to form hydroxide. According to this, just suppose that if I want to convert this, all the three metallic oxides, means M2O, M2O2 and MO2, if I do the reaction, just suppose if a question comes in your mind, what will happen if M2O reacts? M means all the alkali earth metals. Superoxides will react with water, then what you will get, and metallic peroxide will react, then what you will get. Okay. So dear students, whenever we discuss about anything, don't forget to note in your notebook. So this MO2 plus H2. Now question is, if it reacts with generally oxide M2O, what will be the product? Generally, remember this word, that when there is this type first reaction, you will get metal plus and hydroxide minus. Since there are two metals and two hydroxides, you can write 2M plus and 2OH minus. The reaction is balanced. Means if they are in the mono-oxide form, they will give you metal as a cation and hydroxide as a anion. Now if I talk about if they react as a super peroxide, then you will get metal cation, hydroxide anion and hydrogen peroxide. As we have discussed these things into the preparation of hydrogen peroxide also. Okay, so you can see here there are two metals, two hydroxides. So here you can get your reaction balance. M2O2 plus 2H2O gives 2M plus 2OH minus plus H2O2. And last one, if I talk about the super peroxides, similarly in the super peroxide, it will increase one more step. It will gives you metal plus hydroxide minus plus hydrogen peroxide and plus oxygen O2 also. So remember dear student, when we write this reaction, and if you want to balance this reaction, you have to just increase, you have to put 2 everywhere till the hydroxide here. 2MO2, 2H2O, 2M plus and 2OH minus, right? So as you have seen, these are the oxides and superoxides and peroxides of these alkali metals. Now comes about the properties. The oxides and peroxides are colorless when pure, but the superoxides are yellow or they are orange in color. The superoxides are also paramagnetic. Sodium peroxide is widely used as an oxidizing agent in inorganic chemistry. The hydroxides, which are obtained by the reaction of these oxides with water, are all white crystalline solids. The alkali metals, hydroxides, are the strongest of all the bases and dissolve freely in water with evolution of much heat on account of this intensive hydration. So what you have seen here is in the first topic, oxides and hydroxides. All the alkali metals, when react with oxygen, they gives you oxides in the form of mono, oxides in the form of pero, oxides in the form of superperoxides, right? Now as you have seen about the hydroxides, if they react with water, it gives you in the form of hydroxide, it gives you in the form of hydrogen peroxide, and it gives you in the form of hydrogen peroxide plus O2. So this was the first topic, oxides and hydroxides. Now we are moving towards the second topic, that's called halides. Halides also we have discussed, that was the second topic was the reaction with halogens. Halogens or halides. You can say halides means that F2 in the form of halogens and F minus in the form of halides. Now just think that if alkali earth metal reacts with halides, what will happen? It's general question. Halides means you know very well. If we discussed about all these alkali metals from lithium to cesium, lithium, sodium, potassium, rubidium and cesium. So these all are in the form of M. So when this MX, this is called metallic halides. Alkali metallic, okay? Don't forget that. Metallic halides. Right? It can be represented as M plus and X minus. So here they are pure cationic and anionic form. So these alkali metal halides, all high melting colorless crystalline solids, they can be prepared in the reaction of appropriate oxides, hydroxides or carbonate with the aqueous hydraulic acid. Means where X is equal to fluorine to, generally chlorine से start करते हैं, chlorine, bromine, iodine. Somewhere fluorine also. So don't forget about the fluorine also. But somewhere if I talk, because fluorine is highly electronegative, that's why I am writing at the last. Now question is, this metallic halides, if they react generally with the oxides and superoxides, appropriate oxides and hydroxide, or with the carbonate in the aqueous hydraulic acid, All of these halides have high negative enthalpies. High negative enthalpy formation means, delta HF minus. The fluorides become less negative. As we go down towards the group, what will happen? As we move down towards the group, the reverse of the true for delta HF minus for chlorides, delta HF minus for bromide, delta HF minus for iron. For a given metal, delta HF minus always become less negative from fluoride to iron. So maximum delta HF minus, this is the standard enthalpy formation. What it's known as standard enthalpy formation, and this thing we have discussed in thermodynamics chapter. If you have remembered, then this thing we have discussed in thermodynamics chapter, right? So this delta HF minus, standard enthalpy of formation. If I talk about from MF to MI, means metallic fluoride to metallic iodide. As we move down towards the group, means fluorine, chlorine, bromine, iodine. So what will happen? Delta HF values? Delta HF values will always become less negative from the fluoride to iodine. Means the maximum will be of fluoride from chlorine to iodine. That's why I had informed you, because fluorine is a highly electronegative. So it will become less negative as it moves down towards the group. So this was about the standard enthalpy formation, and the melting point and boiling point are always follow through the 10. Means the highest melting point will be of fluoride, metallic fluoride, then metallic chloride, then metallic bromide, and then metallic iodide. All these halides are soluble in water. They are having low solubility of lithium fluoride in water, because it's due to the high lattice enthalpy, where the low solubility of cesium iodide is due to the similar hydration enthalpy of 2, its ion. Other halides of lithium are soluble in ethanol, acetone, and ethyl acetate. That is, lithium chloride is soluble in pyridine also. So now question has came about the hydrides. In the hydrides we have seen standard formation enthalpy, solubility, and the formation of alkyl or methyl halides, not metallic halides, how they have formed, what amount of energy, lattice energy, standard enthalpy of formation, and the solubility things we have discussed in halides. So I hope that all of you have understood about the halides. Now we will move towards, after the halides you can see the salt of oxoacids. Now you can ask me, sir, what is this oxoacids? Right? Oxoacid, many students have questions, sir, what is this oxoacids? Dear student, if you may have heard about the name called oxalic acid, that is C double bond OH and C double bond OH. This is called oxalic acid, right? Many times you listen these all things and sometimes you forget also, right? So oxoacids, those in which the acidic proton is on hydroxyl group, which is an oxo group attached to the same atom, carbonic acid, H2CO3. Just suppose if I talk about H2CO3, you know very well here, carbon is, one side it is attached with OH, another side also OH, and one side is H2CO3. Now you can say here, sir, please elaborate this structure, right? So here the hydroxyl group with an oxo group attached to the same atom of the carbonic acid. So this here OCOH2, sulfuric acid also, you will see the 2 hydroxyl group, sulfurous acid also. All these alkali metals form salt with these oxoacids. They are generally soluble in water and thermally stable. They are carbonates, and in most cases the hydrogen carbonates are also highly stable to heat. As the electropositive character increases down towards the group, the stability of the carbonates and hydrogen carbonates increases. Lithium carbonate is not so stable to heat, but if we talk about the cesium carbonate is much stable. Lithium is being very small in size, it polarizes the large carbonate to ion, so the leading to the formation of more stable lithium oxides and carbonate, then its hydrogen carbonate does not exist in as a solid form. So dear student, first of all about this oxoacids, you should remember that oxoacids means what? Oxalic acid, carbonic acid, sulfuric acid. After this sulfuric acid, this gives you the formation of like sodium bicarbonate, NaHCO3, sodium carbonate, hydrogen carbonate, lithium carbonates. Now question is which one is stable? As we move top to down, means top to bottom, because lithium size is very small, so lithium carbonate is not so much stable. But if we move top to bottom, then cesium carbonates are much stable. As we know very well, sodium bicarbonate we use as a washing soda also, sodium hydrogen carbonate we use as a washing soda also. Okay, so now we are moving towards the anomalous properties of lithium. This point, anomalous property. What is the meaning of this anomalous? I have informed you about that. If you have remembered, then lithium, beryllium, boron, carbon, nitrogen, and here sodium, magnesium, aluminium, silicon, and phosphorus. So this property, diagonal shift property, yes, the anomalous behavior of lithium is due to the exceptionally small size of the atom and the ion. Second one is high polarizing power, that is charge radius ratio, and as a result that is increased in covalent character of the lithium compounds, which are responsible for the solubility in organic solvents. Further, the lithium shows diagonal relationship for the magnesium, which has been discussed already in the lecture number 1. So these are the main properties because of the small atomic size. Second, maximum, you can say that polarizing power, high polarizing power, the charge upon ion ratio, and increasing the covalent characteristics in the lithium compounds and the diagonal relationship, right? So these are the main properties, that's called anomalous properties of lithium. Now very important things we are going to discuss about, that is similarities and difference between lithium and other alkali metals. Means lithium, why we are again separating this lithium, means we have to compare lithium as a one alkali earth metal and other as one. Means lithium will have some special characteristics. Yeah, some of the properties are same in alkali metals and some of the properties are differences also. So first of all we are going to discuss with the differences between the lithium and other alkali metals. Means lithium one side and sodium to cesium one side. So difference, first of all I will tell you about the differences, and second topic we will discuss about the similarities. So lithium has much harder, its melting point and boiling point are higher than other alkali earth metals. Lithium is least reactive but the strongest reducing agent among all the alkali earth metals. On combustion in air it forms mainly monooxides and other forms peroxides and superoxides. Lithium chloride is deliquescent and crystalline as hydrate form, whereas other alkali metals chloride do not form hydrates. Lithium hydrogen carbonate is not obtained in the solid form, while other elements hydrogen carbonates are obtained in the form of solid form. Lithium, unlike other alkali metals, form no ethylide on reactions with ethene. Means lithium do not form ethylene group. If other elements of alkali earth metals reacts, they form ethene. You can say that ETHY and that's triple bond. But this lithium do not form it. Lithium nitrate when heated gets lithium oxide, whereas other alkali metals nitrates decomposes to give nitrogen dioxide and oxygen. If I talk about lithium nitrate, LiNO3, it gives lithium oxide, nitrogen dioxide plus oxygen. But if I talk about sodium nitrate, it gives you sodium nitrate NaNO2 plus O2. And the last difference is lithium fluoride and lithium oxide are comparatively much less soluble in water and other corresponding compounds of other alkali metals are soluble. Means lithium oxides, if we compare about the solubility in water, that are not. So these were the differences. Yeah, that was the differences, as I have right now only discussed about the differences. Differences between the lithium and other alkali earth metals. So what are things we have noted? If you don't have NCERT, then please note first of all comparison of melting point and boiling point. Okay, MP and BP. So if you compare this both, highest will be of lithium in comparison to sodium to cesium. Second, if we compare least reactive but the strongest reducing agent among all the alkali metals, means you have to remember least reactive. This is least reactive but strongest reducing agent among all. Strongest reducing agent. Other than among all, you can see among all the least reactive, other are highly reactive, but this lithium is least reactive and these are more reactive. Strongest reducing agent, they are not stronger, you can say stronger reducing agent. Yeah, okay. Second, if I talk about the oxides, it gives you lithium oxides, but here peroxides and superoxides, right? So now if I discuss after that, the third point, if I discuss about lithium chloride is deliquescent and crystalline as hydrate form. Yes, lithium chloride is giving LiCl2, or you can say LiCl into 2H2O. Lithium chloride is giving you in the form of hydrated. Other alkali metals not give hydrated salts, right? So these three properties as you can write in your notebook. Next, if I discuss, hydrogen carbonate is not obtained in the form of solid, means lithium hydrogen carbonates LiHCO3 does not form in solid state. And rest all the alkali metals MHCO3 form in solid state. Fourth point, in the fifth point if you want to write, then you can write lithium, unlike all the other alkali metals, form no ethanite or in the reaction of ethene, means when the lithium reacts with C2H2, it doesn't give ethene, okay, but other gives ethene. Okay, now the second last you can say the sixth property. Yeah, lithium reacts, lithium nitrate gives lithium oxide, but other gives lithium oxides when react with nitrate, NaNO3, sodium nitrate, it gives you lithium nitrate, right? Lithium nitrate, LiNO3 when reacts with LiNO3 gives you lithium oxide and sodium NO2. Okay, but other doesn't gives, like other gives sodium nitrate. So here NaNO3 will be formed as NaNO2 and O2. So here you can see it is not giving you oxides form as comparison to lithium. And last one, lithium fluoride and lithium oxides are much less soluble, means solubility LiF and LiO. Lithium fluorides and lithium oxides are less soluble in water, but if we talk about sodium oxide to the cesium oxide, they are more stable. So you can write these differences between the lithium chloride and lithium and other alkali metals. So these were the differences. Now we will talk about the similarities. Similarities means you know very well. This was the different properties. Now what are the similarities properties of lithium and other alkali earth metals? Right? So lithium and other alkali metal similarities, if I talk about the similarities between the lithium and magnesium, is particularly striking arises because of their similar sizes. Atomic radius of lithium is 152 picometer and magnesium 160 picometer. Their ionic radii, lithium plus is 76 and magnesium 2 plus is 72. Both lithium and magnesium are harder and lighter than other elements in respective group. Means first similarity is lithium and magnesium. Means this is from alkali and this is from alkaline earth metals. Similarities, okay? Now we are talking about the similarities. So first I have said you about the lithium and magnesium. Means one is of alkali earth metals and another is of alkaline earth metals. So lithium and magnesium are lighter than other alkali and alkaline earth metals. Means this, if we comparison about lithium from sodium to cesium, and here calcium to barium. Okay. So these are the heavy metals in comparison to these two. Lithium is the lighter among all these, and if we compare, so here this question you should write in your notebook, they are lighter than other respective group elements, right? Second thing, we have discussed about the ionic size and atomic size. So these both are having slightly similar. Lithium is having 152 picometer, magnesium is having 160 picometer atomic size. And ionic sizes, lithium plus 76 picometer and magnesium 2 plus 72 picometer. Now the second similarity property, lithium and magnesium react slowly with water. Their oxides and hydroxides are much less soluble in that. Hydroxide decomposes on heating, both form nitride by direct combination with nitrogen. So first similarity was this. Second similarity is lithium and magnesium, if they react with nitrogen, directly they form nitrides, Li3n and Mg3n2. Means directly they form nitrides. But if they react with water, then they are slightly soluble. So remember the questions, dear students. First reaction, they are slightly soluble. Second reaction, they directly form nitrides. Okay. Now third one is the oxides of lithium and magnesium is only formed when there is excess oxygen to give in the superoxide form. Means if you want to convert lithium superoxides or magnesium superoxide, you have to give excess amount of oxygen. And the carbonates of lithium and magnesium decomposes easily on heating. It gives you carbon dioxide, oxides of element in the side, solid hydrogen carbonates, and do not formed by lithium and magnesium. Dear student, lithium and magnesium. Third one, lithium hydrogen carbonate, magnesium hydrogen carbonate. If you compare these both, then can you tell me what will happen? They are, means they bothly carbonates are easily decomposed on heating. They form carbon dioxide and hydrogen carbonates, which are not formed in the solid form. Okay, students? Means lithium and magnesium hydrogen carbonates are not formed in the solid forms. Okay, now next one, if I talk about both lithium chloride and magnesium chloride are soluble in ethanol. Yes, the main property you can write that NiCl and MgCl2 soluble in ethanol. Soluble in ethanol. So very important properties you can write about the similarities about the lithium and magnesium. Last but not the least, both lithium chloride and magnesium chloride are deliquescent and crystalline form in the aqueous solution. lithium hydrate is LiCl into 2H2O and magnesium hydrate is MgCl2 into 8H2O. Means they both are forming a hydrates form. LiCl into 2H2O and MgCl2 into 8H2O. So they both can form in their hydrated form. So dear students, this was the similarities of lithium and magnesium in comparison to other alkali and alkaline earth metals. Now dear student, washing soda, baking soda, caustic soda and sodium chloride. How they are formed, I hope all of you know about it. I will just discuss about it, the reactions which you have note down in your notebook, their preparation properties, because one more topic will be left about the biological importance of sodium and potassium. So first of all, let me introduce from the important compounds of sodium, starting from washing soda, that is NaCO3 into 10H2O. It is a hydrated forms of. First is washing soda. Just dear student, don't forget to write these things in your notebook. Na2CO3 into 2H2O. Preparation, properties and uses I will only discuss. You have to write everything in your notebook. That is the main thing, okay? So we are starting this preparation, properties and uses of sodium carbonate, Na2CO3 into 10H2O. Sodium carbonate is generally prepared by Soluble process. You know Soluble process? In this process, the advantages of hydrogen carbonates, whereby it gets precipitated in the form of reactions of sodium chloride with ammonium hydrogen carbonate. The latter is prepared by passing carbon dioxide to the concentrated solution of sodium chloride saturated with the ammonia, where the ammonium chloride followed by the ammonium hydrogen carbonates are formed. Now you can write in the forms NH3 plus H2O plus CO2, NH3 plus H2O plus CO2. Can you tell me what will be the product? Ammonium carbonate, NH4 whole twice, NH4 whole twice CO3. Yeah, you can write here two ammoniums. Now you can compare the reaction. Is this reaction balanced? Yes, it is balanced. Now this ammonium carbonates again react with same thing, means water and carbon dioxide, means NH4CO3. This reacts with water and carbonates. So can you tell me what will be the product? NH4HCO3, ammonium hydrogen carbonates. Now you can compare the reactions and you will write directly. Here it will be 2NH4HCO3. Yes? Now the reaction is balanced. Now this ammonium hydrogen carbonate reacts with ammonium hydrogen carbonates. NH4HCO3 reacts with, can you tell me? It reacts with sodium chloride, NaCl. It's give ammonium chloride, NH4Cl plus sodium hydrogen carbonates. Right? So this sodium hydrogen carbonate crystal separates, and when they are heated to give sodium carbonate, means this NaHCO3, sodium hydrogen carbonate, is separated in the form of sodium carbonates, means Na2CO3 plus carbon dioxide and water. Okay, plus carbon dioxide and water. So this reaction, as last reaction written on the board, in this process ammonia is recovered when the sodium containing ammonium chloride is treated with calcium hydroxide. Calcium chloride is obtained in the byproduct, means if you react ammonium chloride with calcium hydroxide, NH4Cl plus CaOH whole 2. You know what will be the product? Can you tell me? Ammonium hydroxide plus calcium chloride and plus water. Here this, it will convert into ammonia plus calcium chloride plus water. You can balance the reaction, no need to balance the reaction here. It may be mentioned here as the solvent process cannot be extended to the manufacturing of potassium carbonate because potassium hydrogen carbonate is too soluble to be precipitated by the addition of ammonium hydrogen carbonate to a saturated solution of potassium chloride. Now if I talk about the properties, sodium carbonate is a white crystalline solid which exists as a decahydrate. Decahydrate means this, oh sorry, I need to CO3 into 10H2, not 2, decahydrate. Deca means 10, okay? Na2CO3 into 10H2, decahydrated form. So as you remove this decahydrated one by one, it will be removed. This is also called a washing soda. It readily soluble in water on heating. The decay means you can say that decahydrated loses its water of crystallization to form monohydrate. Means one by one, as you will heat this washing soda, Na2CO3 into 10H2O, you will heat, it will become Na2CO3 into 9H2O, again 8H2O, 7H2O, and last you will get it Na2CO3 plus H2O. This carbonate parts of sodium hydrogen or sodium carbonate get hydrolyzed by the water to form an alkaline solution. Means carbonate will be CO3 2 minus when reacts with H2O, it gives you HCO3 minus plus OH minus. So this was the preparation of washing soda. Dear students, these things we have studied in class 10 also. But why I am discussing here this washing soda, but here there are something different about this sodium chloride, hydrogen carbonates. Now question is, what are the uses of this sodium hydrogen carbonate? Sodium carbonate, it is used in the water softening, laundering and cleaning. It is also used in the manufacturing of glass, soap, borax and caustic soda. It is also used in the paper, paints and textile industry, and it is important in the laboratory reagent both in qualitative and quantitative analysis. Now the rest compound, sodium chloride, baking soda, caustic soda, these are all the properties you have to write in your notebook. So first of all, I will go with, after washing soda, I will move toward directly sodium chloride, last one. The most abundant sources of sodium chloride is seawater, which contains 2.7 to 2.9% of mass of salt. In the tropical countries like India, common salt is generally obtained by evaporation of seawater. Approximately 50 lakh tons of salts are produced annually in India by solar evaporation. Crude sodium chloride is generally obtained by the crystallization of brine solution containing the sodium sulfate, calcium sulfate, calcium chloride and magnesium chloride as impure calcium chloride, CaCl2 and MgCl2 forms. These are the impurities because they are delinquent. To obtain pure sodium chloride, what we do? We take the crude salt, we dissolve in the minimum amount of water and we filter to remove the insoluble impurities. The solution is then saturated with hydrogen chlorides gas. Crystals of the pure sodium chloride separated out. Calcium and magnesium chlorides are separated out. Being more soluble than the sodium chloride, remains in the solution. Sodium chloride melts at 108 Kelvin. It has a solubility of 336.0 gram in 100 gram of water at 273 Kelvin. The solubility does not increase appreciably with the increase in temperature. So dear student, the second I have discussed about the sodium chloride. That is the most important product of sodium. सबसे ज़्यादा important product है हमारा सोडियम क्लोराइड का सोडियम. तो जो मैंने आपको बताया अभी कि सोडियम क्लोराइड किस तरह से इंपॉर्टेंट है, कैसे इंपॉर्टेंट है, ये आप लोगों को बहुत ही ज़रूरी लिखना है. सोडियम क्लोराइड आप लोगों ने 10th स्टैंडर्ड में पढ़ा था कि ब्राइन सॉल्यूशन से कैसे ये ऑब्टेन होता है. जनरली पूरे भारत में 50 टन से भी ज़्यादा सी वाटर को इवापोरेट करके सॉल्ट का फॉर्मेशन होता है. जो सॉल्ट को बाद में ब्राइन सॉल्यूशन से लेकर के क्रिस्टलाइन फॉर्मेशन में कन्वर्ट किया जाता है, और इसके अंदर में जो मैग्नीशियम और कैल्शियम के क्लोराइड्स होते हैं, जो इम्प्योरिटीज होते हैं, जो दोनों पानी में सॉल्युबल होगा। तो पहले इसको हम लोग क्या करते हैं, दोनों को सेपरेट कर देते हैं, लेकिन मैग्नीशियम और कैल्शियम के जो क्लोराइड्स हैं वो भी पानी में सॉल्युबल है, तो उसके लिए आपको टेंशन नहीं लेना है। बट दोनों का मेल्टिंग पॉइंट और बॉइलिंग पॉइंट में डिफरेंस है, तो उसके थ्रू हम लोग सोडियम क्लोराइड को सेपरेट कर सकते हैं और इसका फॉर्मेशन कर सकते हैं। अब रहा यूजेस, तो आपको पता है कि हम लोग घर में नमक के रूप में, खाने के रूप में यूज करते हैं। इट इज यूज्ड एज अ कॉमन सॉल्ट, टेबल सॉल्ट फॉर द डोमेस्टिक पर्पसेस। एंड ये जो है वॉशिंग सोडा, नॉट वॉशिंग सोडा, इट्स कॉल्ड Na2O2, सोडियम पेरोक्साइड, सोडियम हाइड्रोक्साइड और सोडियम कार्बोनेट, ये तीन चीज के प्रिपरेशन में भी इसका यूज होता है। कॉस्टिक सोडा का नाम सुना आपने, NaOH, NaOH। तो कॉस्टिक सोडा में सबसे ज्यादा इंपॉर्टेंट है हमारा ये कॉस्टिक सोडा वाला, अक्सर पूछा जाता है क्वेश्चन। देखिए वॉशिंग सोडा आपने पढ़ लिया, सोडियम क्लोराइड आपने पढ़ लिया, बाकी बचा है दो, कॉस्टिक सोडा और बेकिंग सोडा। सोडियम हाइड्रोक्साइड इज जनरली प्रिपेयर्ड कमर्शियली बाय द इलेक्ट्रोलाइसिस ऑफ सोडियम क्लोराइड। सोडियम क्लोराइड को जब आप इलेक्ट्रोलाइसिस करोगे तब जाकर के आपको सोडियम हाइड्रोक्साइड मिलेगा कैस्टर कैंड्रल सेल के थ्रू। अ ब्राइन सॉल्यूशन is electrolyzed using by mercury cathode and carbon anode. Sodium metal discharge the cathode combines with mercury to form sodium amalgam. Chloride gas is evolved at the end. मतलब यहाँ पर आपको याद रखना है, सोडियम प्लस प्लस 1 इलेक्ट्रॉन gives you सोडियम अमलगम, और क्लोराइड में क्लोराइड माइनस हाफ Cl2 प्लस इलेक्ट्रॉन। तो ये जो अमलगम है, इसको वापस हम लोग पानी के साथ रिएक्शन करते हैं तो सोडियम हाइड्रोक्साइड के रूप में वो हम लोगों को मिल जाता है। तो सोडियम हाइड्रोक्साइड जो है एक व्हाइट कलर का ट्रांसलूसेंट सॉलिड है जो 591 केल्विन पर मेल्ट होता है। हाँ, इसको पानी में तुरंत घोल दिया जाता है, ये स्ट्रॉन्ग अल्कलाइन सॉल्यूशन होगा। क्रिस्टलाइन ऑफ सोडियम हाइड्रोक्साइड्स आर डिस्टिंक्ट। सोडियम हाइड्रोक्साइड सॉल्यूशन एट द सरफेस रिएक्ट्स विद कार्बोनेट इन द एटमॉस्फेयर एंड इट गिव्स यू सोडियम कार्बोनेट। इसका यूजेस की मैं बात करूं तो इसका यूजेस मैन्युफैक्चरिंग ऑफ सोप पेपर, आर्टिफिशियल सिल्क एंड द नंबर ऑफ केमिकल्स ऑफ बॉक्साइड्स, टेक्सटाइल इंडस्ट्री में इसका यूजेस होता है, प्रिपरेशन एंड प्योर फास्ट एंड ऑयल्स में एज अ लैबोरेटरी रिएजेंट आल्सो। तो ये था हमारा सोडियम क्लोराइड, वॉशिंग सोडा हो गया, कॉस्टिक सोडा हो गया और सोडियम क्लोराइड। अब लास्ट बचा है बेकिंग सोडा। ये तो आप लोगों ने 10th स्टैंडर्ड में पढ़ा होगा, हाइड्रोजन कार्बोनेट जिसका नाम है बेकिंग सोडा, NaHCO3, राइट। NaHCO3 जो हाइड्रोजन कार्बोनेट है, इसको बेकिंग सोडा के नाम से जानते हैं। जब आप डिकम्पोज करोगे हाइड्रोजन कार्बोनेट्स को, so as I have said you about the baking soda, which is also known as sodium hydrogen carbonate, उसकी प्राप्ति जो है हम लोग बस वही सोडियम कार्बोनेट को हाइड्रेटेड फॉर्म करके सोडियम बाइकार्बोनेट के फॉर्म में हमको मिलेगा। सोडियम हाइड्रोजन कार्बोनेट इज मेड बाय द सैचुरेटिंग अ सॉल्यूशन ऑफ सोडियम कार्बोनेट विद कार्बन डाइऑक्साइड। द व्हाइट क्रिस्टलाइन पाउडर ऑफ सोडियम हाइड्रोजन कार्बोनेट इज बीइंग लेस soluble which will be get separated। मतलब सोडियम कार्बोनेट को तुम वाटर के साथ रिएक्शन करो, कार्बन डाइऑक्साइड बाहर निकलेगा और सोडियम हाइड्रोजन कार्बोनेट तुमको मिल जाएगा। ये जो है मिल्ड एंटीसेप्टिक फॉर स्किन इन्फेक्शंस के रूप में भी इसको यूज किया जाता है और फायर एक्सटिंक्शन में इसका यूज होता है। तो ये था हमारे कुछ सॉल्ट जो सोडियम के थ्रू बनता है। वॉशिंग सोडा Na2CO3 into 10H2O, याद रख लेना सारे का केमिकल फॉर्मूला। बेकिंग सोडा NaHCO3, कॉस्टिक सोडा NaOH, सोडियम क्लोराइड हो गया NaCO, राइट। तो ये चारों का प्रिपरेशन, प्रॉपर्टीज और यूजेस हमने पढ़ा। और लास्ट टॉपिक आज का रहेगा हमारा बायोलॉजिकल इंपॉर्टेंस ऑफ सोडियम एंड पोटाशियम। तुमको पता है पूरे शरीर में हमारे मिनरल्स पाए जाते हैं, तो कितना परसेंटेज कौन सा मिनरल्स पाया जाएगा उसके बारे में हमारा ये लास्ट टॉपिक है, बायोलॉजिकल इंपॉर्टेंस ऑफ सोडियम एंड पोटाशियम। A typical 70 kilogram man can contain 90 gram sodium and 170 gram of potassium compared with only 5 gram of iron and 0.06 gram of copper। पूरे शरीर में अगर कोई मनुष्य 70 किलो का होगा, 70 केजी अगर उसका वेट है, तो उसके शरीर में 90 ग्राम सोडियम होगा, 170 ग्राम पोटाशियम होगा, और आयरन और अगर कॉपर का कंपेयर करोगे तो 0.06 ग्राम कॉपर और 5 ग्राम आयरन। तो तुम समझ सकते हो सोडियम और क्लोरीन का क्या इंपॉर्टेंस है हमारे बॉडी में। सोडियम आयंस आर फाउंड primarily on the outside of cells, being located in the blood plasma and in the interstitial fluid as surrounded in the cells. The ions are precipitated in the transmissions of nerve signals, which is regulating flow of water across the cell membranes, and it is transport of sugars and amino acids into the cells. Sodium and potassium, although similar chemically, differ quantitatively. Their ability to penetrate cell membrane in the transparent mechanism, in their efficiency to activate enzymes. The potassium ions are most abundant cations within the cell, so they are active. Many enzymes participate in the oxidation of glucose to produce ATP, and the sodium and responsible to transmission of the nerve signals. तो प्यारे बच्चों, सबसे पहले मैं आपको बता दूं कि पूरे शरीर में हर आयन का उतना ही इंपॉर्टेंट है जितना, अगर तुम सब्जी में अगर नमक नहीं दोगे तो क्या होगा। अगर तुम्हारे शरीर में सोडियम की कमी हो जाएगी तो क्या होगा पता है? You will not be able to wake up, you will not be able to stand. हर मिनरल का इंपॉर्टेंट है। तुमने अभी जस्ट सुना कि प्लाज्मा में जो इसका फ्लो होता है, बायोलॉजी वाले स्टूडेंट ज्यादातर इन लोगों को पढ़े होंगे कि जिस तरह से सोडियम और पोटाशियम हमारे सेल मेम्ब्रेन में ट्रांसपोर्ट करते हैं, तो सारे एंजाइम्स जो केटायन और एनायन फॉर्म में पाए जाते हैं हमारे बॉडी में ग्लूकोज या एटीपी को बढ़ाने में इसका काम किया जाता है। पोटाशियम आयन जो है स्पेशली सेल मेम्ब्रेन्स के अपोजिट साइड्स में, एक टिपिकल एग्जांपल है ब्लड प्लाज्मा का, जो सोडियम हमारे बॉडी के अंदर में 143 मिलीमीटर पर मोल पर लीटर के रूप में प्रेजेंट है, और पोटाशियम जो है सिर्फ 5 mm पर मोल के रूप में हमारे बॉडी में प्रेजेंट है। रेड ब्लड सेल्स में होगी, याद रखना। ये जो कंसंट्रेशन होगा 10 mm पर मोल सोडियम का और 105 mm पर मोल पोटाशियम का, इनके जो आयनिक ग्रेडियंट्स हैं वो डिस्क्रिमिनेटरी मैकेनिज्म के थ्रू टूटता है, और सोडियम पोटाशियम पल्प जो शरीर में एक जैसे हार्ट में ब्लड पंप पल्प करता है उसी तरह से यहाँ पर ये पंप करेगा, और 1/3 ऑफ द एटीपी इज यूज्ड बाय रेस्टिंग एनिमल एंड अबाउट 15 kg पर 24 आवर इन रेस्टिंग ह्यूमन। प्यारे बच्चों देखो, वैसे तो ये बहुत ही इंपॉर्टेंट चीज है जो बायोलॉजी फील्ड में जाना चाहते हैं उनके लिए तो बहुत ही ज्यादा इंपॉर्टेंट है कि बायोलॉजिकल इंपॉर्टेंस ऑफ सोडियम एंड पोटाशियम। हमेशा कुछ ना कुछ नया सीखने को मिलता है। तो आज जो था ये हमारा जनरल कैरेक्टरिस्टिक्स ऑफ अल्कली कंपाउंड्स, जो हमने फॉलोइंग टॉपिक्स को कवर किया। अगर कुछ भी चीज आपको नहीं समझ में आया होगा then don't forget to write your doubts into the comment box section. That's all for today. Thank you very much. Don't forget to like and subscribe the channel, share with your friends, that can be benefit to your friends. Thank you very much.